All right, hello everyone. How's it going? What we've got here is the second page of notes from section 5, and we're going to solve equations or polynomial equations. The steps in your notes: set the equation equal to 0. Make sure your terms are going in descending degree so you can factor them. Factor, and then apply the zero product property. I picked out a couple from your second page of notes to review with you. So let's go. Look at the first example in your notes. X squared plus 10x equals negative 21. So the first thing you notice is that you've got a term on the other side of the equal sign. We want to bring everything over to the same side. So since my quadratic term is positive where it sits now, I'm going to leave it where it is and bring everything to that side. So I'm going to add 21 to both sides of this equation. And that's going to result in x squared plus 10x plus 21. And now I have my equation set equal to 0. Once it's set equal to 0, I'm going to look to see, do I have any common factors? And I do not. And since it's a trinomial, I'm now going to try to break this into the product of two binomials. So I'm going to write my parentheses down, keep my equal 0. Split up that x squared and do x times x. Two factors of positive 21, and that's got to be 3 and 7. And they have to add to positive 10. So that's going to be positive 3 and positive 7, or vice versa. It wouldn't matter which way you listed them. And now I've got something times something equals 0. So I can apply the zero product property and set each piece as equal to 0. So either this binomial must be 0 or this binomial must be 0. And when I solve each one, subtract 3 from each side, subtract 7 from each side, x is equal to negative 3 or negative 7. And you just solved your first polynomial equation. If you go back and you put either one in here, you're going to get a true sentence. Let's do it again for our second example. Again, I've got a term on the other side of the equal sign, so I want to make sure I bring everything to the same side. I'm going to bring everything to the side that makes the x squared term positive, so it's already positive right here. So I'm going to subtract 12x from both sides to bring this guy over. So now x squared, and when I do this, I'm kind of thinking in my head a step ahead. So when I subtract 12x from here, and when I subtract 12x from this side, I'm going to place, there's nothing to combine this x to the first power with. So I'm just going to make sure I slide it into the proper spot where it would go in descending degree of my terms. And then the positive 11 would drop down where the constant usually goes. And on this side, I have opposites. That's why I subtracted 12x. And my equation now is set equal to 0. There are no common factors, so I'm going to factor by breaking it into two binomials. I'm going to split the x up. And now I need two numbers that multiply to give me positive 11, but that combine to give me negative 12. 11 is prime, so I can only pick 11 and 1 here, so I know they have to go in there. And since I have to add up to a negative number with the same signs, I know I have to have minus 1 and minus 11. Now I can use the zero product property. Since this times this equals 0, one of these, at least one of these must be 0. So x minus 1 equals 0, which gives me x is 1. Or x minus 11 equals 0, which gives me x is 11. So x is equal to the set of 1 and or 11. There you have it. Now, part 3 of your notes is the same task, but the verbiage is different. It says, find the zeros of the polynomial function. So when we talked about functions before, function notations early in the year, we discussed how this is really the same as the output, or the value of the function is equal to this. X is our input. So f of x really is our y. It's also our zero here. We're going to find the zero, so we want to find the values of the function that are going to result in 0. So all you really need to do is replace that with a 0, and you are ready to rock and roll. Now there is nothing different than what we just did in these first two equations. Maybe you can say the zero's on the other side, but that doesn't really matter. I got a positive x squared term, so I'm going to look for a common factor. There is none. So I'm going to break it up into two binomials. First times first has to be x times x. And now factors of negative 56 that have a sum of positive 3. So when I have a negative back term here, I know my signs have to be mixed. Sometimes I can just write in a positive and a negative. I have to have mixed signs to get a negative product. So, now that means my outers and inners are going to have opposite signs. So I'm thinking subtraction. I'm really thinking 3 apart. And now, to be honest with you, this is all the wrong number. It's 54. That's going to make it a little easier because it's going to work out. It's going to be 9 times 6. And they have to have, the outers and inners have to combine to be positive 3. So I need my bigger number to be positive and my smaller number to be negative. I'm going to just real quickly FOIL this to make sure I'm okay. First times first, check. Outers, negative 6x. Inners, positive 9x. That does add up to positive 3x. That's the one you got to check. Always just make sure your signs are okay here, and we're good with the negative 54. Bring down my equal 0. This binomial times this binomial equals 0, so one of these must be 0. So we got the same ending here as the other two problems. X is negative 9, or x can be positive 6. So these are the zeros. And our zeros are important, especially as you move on in math, because that's going to tell you where your graph of these cross the x-axis. We're going to cross the x-axis back here at negative 9 and over here at positive 6, and we'll be graphing these things very, very soon. All right, that's the back page of section 5. Now go practice all the problems, look at the answer key for the notes, and also check your work on the practice sheets as you go along. All right, good luck.